All right. So this is like our typical problem, right? Where we have an artist and then we have like albums, right? And the way that we've done this, let's make this a little. So the way that we've done this, right, is we've done basically like a join, right? Meaning that we've lined up, if you think about this, this is like select all from albums. So this loads up the albums table into memory. And then we'll do join artists on, right? So this is now loading up the artist table into memory. But we want to say how these two things align. So this is going to be join artists on, basically where artists.id equals, so artist.id equals the artist ID, or we should probably say albums.artist.id. Okay, and that's going to line up and basically attach, like where we see a 1 here, that will attach this row for Prince, again I'll attach this row for Prince, and then here I'll attach the row for Paul Simon, right? So it's lining these up. The issue that can arise is, what if, let's say we do it, let's say we add a new column here, and we say, you know, this is like Elvis or something, and I don't know where he's from, let's say Indianapolis. All right, so we have a new artist here, but we don't have a corresponding album. All right, this is the issue, where you have something in one table. So we have this artist that has a primary key here, but there is nothing in the table here that has a foreign key. So if you just do a normal join, right, and maybe we'll rewrite this. We'll say select all from artists. Select all from artists, join, and I'll show a couple of the examples with this, by the way. So select all from artists, so that's going to load up all the records in this table, join albums on artist.id equals albums.artist.id. And here's kind of the question. The question is, so when we get to Elvis, there is no corresponding like record to link up, right? So the question is like basically, do you want to see Elvis even though he doesn't have albums, right? Because if all you really care about is like, you know, the albums ultimately, it doesn't make sense to see the columns relating to Elvis, and then you might see just like null values, right? So when it came to this guy, you would see, you know, like null values here for everything related to an album, right? Because there is no album here. For Prince and Paul Simon, you would see, you know, their name followed by each of their albums, right? It would be like Prince, you'd have the very best of Prince, Prince, Forever, Paul Simon, Stranger, and then the question is, do you want to see Elvis or not? If we do an inner join by default, and even if you don't have this word inner join, if you just have join, by default it will be doing an inner join, and that what that means is you will not see Elvis. All right, you're only going to see those records where there is an artist ID that has at least one corresponding album ID. All right, so that's an inner join. Must be a corresponding foreign key. Right, so Elvis doesn't have a corresponding foreign key, and therefore we would not see him. With an outer join, all the records in the left table will be displayed regardless. By the left table, I mean, if you think about it, we're loading two tables here. Select all from artists. This comes first, right? It's on the left-hand side, just verbally, right, or textually from this join albums. So if we said select all from artists, outer join albums, Elvis would still show up. okay? And you'll see null values next to each of these albums attributes. So it'll be like number of songs, null, right? Name, null. The album ID would be null, okay? So that's this difference between inner join and outer join, right? By default, you have SQL will be using an inner join, meaning that if this record, unless there is there's at least one foreign key that matches the primary key, it's not going to show, right? With the case of Elvis, we don't have a foreign key that matches its primary key, so it's not going to be displayed. With an outer join, it's going to load up all the records, even if one is not being even if it does not have a matching foreign key. So with an outer join, Elvis would be displayed. And I can show this. Khan Academy has an example of this, so we can show this here as well. So this may make it a little easier. What do we have? We have students, right? And then we have student projects. And you can see that we have this table where we have a student's ID. This is the primary key, and then this is the foreign key, right? That links to students. So if you want to see all of the all the students in the projects, we're going to be joining these two tables together. And they're nice enough so that we have more students than we have student projects. So not all of the students have a student projects. So let's do a full outer join, let's do a left outer join first, and we'll see what happens. So we'll do select all from students, right? So this is loading up all the records. So we have two students here. And then we'll do join student projects. So now we're loading up into memory this table, join student projects on student projects dot student ID equals students dot ID. And notice what just happened here, which is by default we're doing an inner join, and we just lost Alice, right? We originally started with Alice, and we just lost her once we did the join, probably because Alice does not have a corresponding project. Let's see what happens if we do a left outer. We could just use the word left join, apparently. So notice now we have Alice. If I can scroll over here, see this? When it looks for joining the student project, we don't have a corresponding student ID, right? This is the student projects table. So all these values are null, but it's still loading up all the records in the table, in this left table, regardless of if there's a corresponding record in the join table, in the right table, okay? If I do an inner join by default, these guys are gonna disappear. All right, so this is an inner join. And notice here, we only see the records on the left table where there is a corresponding project. Make sense?
So basically, like inner join is like acting as an intersection?
Exactly right. Yeah.
Okay.
Maybe I can, I was gonna do this with a whiteboard originally. So, if we have our let's say we have, this is my students table, and it has the ID and name. This is my student projects, and it has, I guess, like we'll just put the let's say we'll do the ID and then the student ID here. The inner join, here I have this is Bob, and this is 1, 2, and this is, let's say this is student ID 1, this is student ID 1, and then we'll have student ID is 2, this is Alice. All right. If we do an inner join, then that means only the intersection is showing up, meaning only those tables, or only those records where it's showing up in both tables, where the student ID is showing up in both tables. So Bob will be shown, but not Alice. This is with an inner join. With a left join, all of the records on this table are going to be shown. Okay? And for here, we'll just have null values. Now, the next question maybe is, well, what if we have a student ID of 3? Okay, will this show up? And the answer is no, not with a left outer join, right? So with a inner join, this is the intersection. With an outer join, with a left outer join, which is what you get if you just write the words outer join, then this is going to be all the tables on the left, all the records on the left, but not, we can just call these orphans. Like that's what you'll hear, I think, in engineering, right? Because it doesn't have like a corresponding sibling or whatever. Anyway, so but not the orphan records. With a full outer join, this is like the union, right? Here, all the records on both sides. So what will you see with a full outer join? If you join the tables, this one will also be shown, and it will just have, you'll have the student project row, but you'll have null values over here, right? So in this case, with a full outer join, you'll have null values on the left, and then we'll also show this record where there will be null values to the right, right? But both, all the records from each table will be displayed with a full outer join. When do you want to show something like that? Like, when does this stuff matter? Well, like, if you think about a funnel, right? Like let me see if I can give another example. If you think about, when we're going to see this in an example, if you think about people that like go to my website, right? People that maybe visit the homepage, and then I have a table of people that visit, like the buy page. If I do an inner join, I'm only going to get the people that do both, right? But if I do a left join, then I'll get the people that first visit the homepage and then do not visit the buy page as well. So I'll be able to see some percentages, right? Maybe I can like calculate the percentage who visit the homepage but don't visit the buy page. What you won't get with the left that is like the people that just visit the buy page, right? Maybe there's some people that go directly to the buy page, but not to the home page first somehow. So that you would need like a full outer join to see both, Here we have a check mark here. So this will just be, this will be just the inner join is where you have both. The outer join, the left join is where you have this, but you don't have this, right? That's left. And then full would include, we'd also have this row, right? But you don't have this, right? This would be full.
So how we can distinguish like which table has to come to the left? Is depend upon the query or?
Yeah, you can. This is where you will have to be kind of like deliberate. It's like, what do you want to see all of the records of, right? That would be your left-hand table. So unless you're doing, so in this case, that would be your left-hand table. So for instance, if I want to see all the people that visited the homepage and the people that visited the homepage but not the buy page, then I would do select all from homepage, and that comes, because I say, let me put it this way, select all from homepage, join buy, right? HP, it just visually is to the left of buy. So left just means the table that comes first in your query, right? And in this case, I'll get all those who visited the homepage, even if they did not visit the buy page, even if I don't have a record for them on the buy page, right? If I do a select all from, by default, this is join, but this is an inner join, so you can put the word inner or not. By default, it's going to be an inner join, and you'll say join by on, you know, there's some sort of user ID probably, something like that. Let's go back to here. So just see this again over here. So you can see in this case, right, select all from students. By default, we have an inner join. So notice again, there's no Alice because Alice doesn't have a project. Once I do a left join, then we show Alice, or in other words, we show all the records on the left-hand side, even when Alice doesn't have any corresponding project. Okay. Now, I don't know if we have a, you know, for a full outer join, I don't know if Khan Academy will, like that's even more rare, but it's possible. Let's see, select all from projects. I think the question is, for me, oh, it's called student projects. Yeah, we only have one student project, so there is not, let's see, do we have any student grades? Yeah, so here, you know, we have all these student grades, one for each student. So it kind of doesn't matter, right? There are no orphans in this case, so it doesn't really matter. But if I'm going to student grades, join the student projects, right? You kind of have to be careful. Join student projects on student grades.id, student grades.studentID equals student projects.student ID. Notice we just lost a bunch of grades. Why? Because again, it's only one of our students that has a project, and the orphan records, those where there is no student project, those disappear. So all of Alice's, all our student ID 2 records disappear. Make sense? If we did a left join, we'd keep them. Left join, now all of a sudden we're always including Alice's records, but we just say, okay, she doesn't have a project. Make sense? All right. I have some problems on this. Oh, there's one other thing I want to show you. Let's say we want to count up the students who have, let's just join on students right now. Select all from students. Left join students on students dot ID equals student projects dot student ID. So that we are joining together the students table, and let's join together the sorry, I think I'm doing this wrong. Select all from students, join students on students.id equals students projects dot student ID. So I'm going to just write it again. Select all from students. All right, so there's students. Join student projects on students.id equals student projects dot student ID. Okay, so we're only showing Peter because there's no corresponding student project for Alice. Let's do a left join. This way we still show Alice. Okay, so now so far, when we've been doing counting, we've done count star. Okay, and we'll get 2, right? Because there's 2 records here. We could also count on, right, like a column. So let's say we count on like the first name. Now this should also get 2 because there's 2 first names, right? Count first name. We also get 2. Now, what if we count on ID? In this case, there's null values. Or let's count on student ID, on student projects.student ID. In this case, we have some null values. So we have select student projects.student ID, and let's do a count on that. Notice we only get 1. So in other words, when you do count, if you count on a column, it's only going to count the non-null values. That's what you're adding up. Okay? So where does this become useful? Let's say I want to find the number of students, or the number of student projects, and also find the number of student, right? We could say number of students with student projects. So this will be as students with projects, right? So we have one student with projects, and then if I want to do total students, that'll be count students.id. This is total students, right? It's kind of like back to our funnel problem. We have 2 students in our class, one of which who submitted student projects. Does that make sense? So we're taking advantage of the fact that, hey, we're going to get null values where, for Alice, because she didn't submit any project, right? And so when we count it, we're only counting, this one guy's. You might have to worry about it a little bit more than that if, say, Bob or whatever his name was submitted more than one project. You might have to do a distinct or something like that to, I'll let you guys fiddle with that. But, right, this is something I wanted to show you all. Is like we're taking advantage of the fact that count is counting non-null values, right? And when we do our left join, we get some null values, right? We get the fact that, okay, we get Alice when it comes to her ID, but we don't get her when it comes to anything on the student projects table. Yeah? Okay. So I do have some practice problems with these. These get into this is more challenging, but I feel like, it's a good time for it. So I'll deploy these readings, give you guys an hour and a half or something to look at it. We're getting into some leak code problems here, all right? Or maybe even leak code medium. But I think you'll be able to handle it, or at least give it a shot. Questions?
Hey, Jeff.
Yeah, go ahead.
Sorry, I had a question. I've seen one person write a query, and after the on keyword, they had 2 separate sort of joins going on. So it'd be like on students.id is equal to student projects, and then another sort of similar clause. What is the reason for something like that?
Join on student projects. Oh, and then another on or something here?
Yes, yeah.
You can basically, how with a where clause, we'll have where, students.name equals Bob. These on clauses work like where clauses. So you could say and students.id equals 1. So let's see if we could. I don't know with select all. Join this. Oh, let's not do a left join. So here we have 1. What if I did 2? See that? And it disappears.
Okay.
So you can, these on clauses basically just work like where clauses. All right. So here it's listing all the student IDs and then listing all the student projects, that's student IDs, and matching them up, saying, okay, where do they equal each other? Here it's saying, and then it's saying, and where the student ID equals 1. So here we have Peter Rabbit. Once I change this to say, 2 or 100, where there is no student ID that equals 100. Mm-hmm. All right. So let me, I'll deploy these. This will have, the reading, these, this stuff. There's also, let me also send out the Khan Academy. Okay. So here's what we want to do. We have this data of web users and mobile users. So we're first going to take a look at our web users. We have basically a user ID, right? And then this is just like a index. And then we have the mobile users. And now this is also a user ID. Okay? So essentially what we want to do, the question is, find the percentage of web users who are not mobile users. Okay, find the percentage of web users who are not mobile users. So let's think about this. Let me try to share. Let's just start with easier. What web users, percentage of web users who are not mobile users? So I think we need both, right? Because we have web, we have mobile. So this guy, let's say this guy's web and he's mobile, and this guy's web and he's not mobile, and this guy is web and he's also not mobile. So the percentage, so the web users, crap, maybe I should have done it the other way, who are not mobile users. Okay, yeah, so these are the two web users who are not mobile users, right? So it's 2/3 of the web users are not mobile users, right? These two divided by this whole set. So in other words, we want to load up all of the web users, and then let's start to write this down. Load up all of the web users, and then find those where mobile is null. Okay. So this should be my left. We want all, like the key thing is we want all the web users. So this should be my left table. And then I'm going to join my mobile table, right? And then where there's no web users, we'll have null values there, right? And then we'll count up, basically. And we can divide all of my web users by the number where these are null. Yeah, that should work. So let's translate this to code. So I load up all the web users. Let's do that. I'll put this down here. So let's start here. So load up all the web users. Select all from web. Great. Web users. Okay, select all from web users. Now we'll do a left join mobile users. And I'm just going to I'm just going to say select web users dot user ID from web users, left join mobile users on mobile users dot user ID equals web users dot user ID. And I want to select both this and both the web user ID and the mobile users dot user ID. Now I'm going to put as mobile user ID. Did I spell that right? No. This will be as web user ID. Okay, so here we're starting to get some data. Okay, so we have all the web users. Notice there are no null values in the web user column because we're loading up the whole table basically of web users. And then where there's mobile, and then even when there's no corresponding mobile user, we have a null value here. Okay? Here's what's next. Find those where mobile users is null, right? Because we want the percentage of web users who are not mobile users. So in other words, we see like 2 here that are null. So we want to find those where mobile users is null. So what can we do there? Instead of this mobile user ID column, we can do case when, and I know we did not, I'm sorry that we did, it seemed like this required case when. I did not realize that. So case when mobile users dot user ID is null, then 1 else 0 end. As let's just put this, is there a mobile user ID? Okay. So when we have a null value, so I should put this like no mobile user ID. When we have a null value, then we're going to put a 1 here, right? This is because we want to find those where the mobile is null, right? Find those users where mobile is null. So when we get a null value here, like for this guy, we'll put a 1. Otherwise, we'll put a 0. And we're going to try that. Okay, so you can see they're basically, these are the places, everything that's a 0 is where, okay, we do have a mobile user, but these are kind of the special cases where we got someone to pay for web, but they're not using our phone service for whatever reason. Okay? So now what do we do? Now we can, well, one, we can sum this, okay? So if we sum this up, we'll get the total number of users, of users who are using web but are not using mobile. So let's just do sum for now. And what do we get? We get 294. Forget about this. This is nonsense. We get 294 users who are using web but are not using mobile. Okay, how did we get that? We had that column of zeros and ones, right? It's a 1 whenever this is a null value. And so when we sum them all up by ones, right, we just are effectively doing that. Notice you cannot do a count. Let me just show you this. If you do a count, we get 1,256. Why do we get so much more? Remember what count does. Count counts up the present values. So to count, when it sees a 1, it counts that as 1. That is present. When it sees a 0, it also counts that as present. Right? 0 is not null in SQL. So this is why, like, I got confused by this too. Count will not work. We have to do a sum. Okay. So now what do we got? We got 294 of these people are not using mobile, but they are using web. Otherwise, they wouldn't have been in our select statement in the first place, right? So now what we can do, we can probably just divide this. If we do, let's see, if I just do count star, as total users, how many do I get? 1,256, same number that we saw before, right? So now we probably can just divide this by the total number of users. Let's just try it. Divided by count star. We may have to times by 100, or I don't know. We'll see. Yeah, it seems like maybe we have to take time.
It's because of translation. We had this issue. You have to cast it to a float.
All right. If I do, let's try this. Cast this. So let's take this thing and then cast as float. Hold on.
I think you have to cast it before the division. So if you cast any of the terms in the numerator or the denominator, should be enough.
Okay.
Multiply the numerator by like 1.01.
That might also work. Let's try that.
Yeah, you could multiply by 100.
Okay, so let's do 1 point.
Yeah, you can do 100
1.0
times
times by
100.0.
this. All right, let's try if that works. That seems to work.
Yeah, you could do the subtraction and then multiply by 100.
Yeah, if we reversed, like, so this gives us the right answer because we're counting the null values as present. The other way to do it is, you know, count the present value, you know, whatever. I'm not going to say it. And then subtract by 100, right? So in other words, if I want to find, or just maybe another way to put it is, these right now, these are all of the all the cases where we have web but we don't have mobile. If we want, I don't even know if that's true. I'd have to rethink it. If we want where we have mobile but not web, because you probably have to do a left join on the other side too, on the other table. But anyway, this hopefully made some sense. So we got the percentage by multiplying this top number by a float, which then allows us to see this. Let me see some of these questions. Okay, can't you do this without a case when? I don't think
I think we did it. I posted
Really?
the query and our answer
Yeah.
was right.
Yeah, we did it without a case one as well.
Oh, nice. Okay, well, that's great. I changed
Yeah.
my answer.
Oh, you guys use a left join there.
Yeah.
Yeah.
You use a left join, which filters by itself the mobile users, the web users that aren't mobile users, and then from there you can then multiply by 100 or do whatever afterwards.
All right, let's go through this other solution that Chuma posted. So, all right, so in this case,
I didn't post
Okay.
that one.
that someone posted kindly. Okay, so let me just go through this solution one more time, and then we'll go through the next one and see if we can understand it. So in this solution, right, we're doing this case when, and basically the key thing was, you know, we said, okay, when mobile users.user ID is null, then 1, otherwise else 0. So we're basically saying, okay, count up. That's not what I wanted. Oh, because I have this count star. We'll just say select user ID. This is the web users. Sorry. Select from web users. Okay. So you can see we have all the web as let's just call it as web user ID. All right, so here we just have the user ID, and here we're counting up, or we're like beginning to count up, where is there a null value here, okay? And then from there, and we're doing that by saying, okay, when this thing is null, then put a 0. When my mobile user doesn't exist, we did not get this person assigned for mobile, place a 1 value there, place like a ticker, all right? Then the next thing we'll do is we'll add up, right? Not count, because count counts zeros, but rather add up, sum the zeros and the ones together. All right, that gives us the 294. Then from there, we can divide this by the total number of users, which is count star, right? My whole data set. And then it seemed like we had to coerce this into a float by multiplying. The easiest way we found was just by doing 1.0, right? Multiply the numerator by a float, and that will be okay. Let's see if that works. Right, and that got us the percentage. I'm gonna post this answer as well. All right, here's the other way, apparently. Let's see if we can get it. So let's kind of break it down. Take this out for now. We're gonna do, this is still a left join. I'm just gonna put this here, select star for now. So we're selecting all from web users. So notice still giving all the tables, all the records of web users. Left join the mobile users on the right, on the correct columns on this standard where the user ID, web user ID equals the mobile user ID. So this is starting out the same way. And I need to do a couple things. That's my query. And let's just select the user ID. We'll start the same way. Web user.user ID, comma, mobile users.user ID. Okay, so we see all of my web, and let's call this as web users, and we'll say as mobile. Okay, so all my web users are present, and because we're loading up all that entire table, and then we have, again, some null values for the mobile user ID. Okay, the next thing is, I guess, we're going to count the web users.user ID. This will, each one of these are present, so this will give me the total number. So let's say there's like 100 here, right? So it'll give me 100. And then I'm going to do minus, let's say there's only 75 here. So that will give me minus 75, where we have the mobile users present, right? Because we have a couple of these where these are null, right? So that's going to give me 100 minus 75, which will give me 25. Which seems to be kind of right, and this, if we take this, divide by, I think you'd have to divide it by the total number of users, right? So that'll give me 25%, something like that. Let's see. So this time we'll do select count of the web users minus count of the mobile users. So this is the number of more, like how many more web users are there than mobile users, I think, for now. So we have, there are 294 cases where there are web users as web, not mobile. And then if you want to do the percentage of web, not mobile, you'll have to say, okay, hold on. So let's count this. Oh, shoot, we'll have to cast it again. 1.0 times by this whole thing. Damn it. Maybe this is just
multiply sign, right?
Oh, I did miss the multiply sign. Yeah. Okay. So wait. Oh, we got the same exact answer. Okay, now we have to understand how we got it right. So this is 100. Like, let's say there were 100 total web users. We counted up 75 mobile users, right? And then the difference is going to lead us to 25. Then we take that total difference, divide by all the number of web users, and that gives us the percentage. So I think that's why this is right. Let me see if there's questions. That is challenging, I think, to me. Oh, wow. Or we can use an average function. Oh, that's pretty cool. Okay, that's pretty clever. That's pretty nice. The average is smart. So let's post this in here too. And then, like I said, I'll save this as a gist, and then you guys can look through these. Hold on, let me get that answer. I think the idea with the average is, well, you don't have to divide. Like, it kind of does that division for you. So here we have so let's start here. Well, we'll start without the average. Okay, so what do we get? We have one column as, web not mobile. Okay, so we have one column of, these are all, we have a row for every single web, because again, we're doing a left join on, starting with the web users. This is our left table, so we have every one of our web users. And then there are cases where the mobile user is not there. And where the mobile user is null, we put a 1, okay? Now, if you add up all the ones and divide by the total number of rows, that's the definition of the average. So we don't have to do like we could do this. We could do a sum of all this divided by count star. That's one way to do it, I guess. But we have to times by 1.0 to make it a float. There you go. So you could do the sum divided by the total amount, or you could just do the average, and then you don't have to do this division anymore. And that gives you the same answer, right? Because on average, there's a 1 23% of the times, right? So if you take 23 and divide by 100, right? That's the definition of the average. My brain is hurting. Okay, and then let's just copy and paste the other one here. I don't know if I can walk through it. I'll post this last one. I think I'm tapping out, but I'll post it. So let me save these. This seems pretty tricky. Let me save these as a gist, and I'll let you guys go through it. Take a break. Feel free to take like a 10-minute break. We'll post this. Maybe take like 15 minutes to look through this. Then I'll post some of the object orientation readings. All right. You don't have to get through the rest of we can stop there in terms of SQL stuff for now. So I'll post the rest, like a couple object orientation readings, and let's say we'll come back probably around like a little after 3, like 3:10, something like that. All right, so let me save this as a gist.